Everyone, welcome back. I haven't posted in about a year, but I've still been working pretty hard on version 14 or V14, which is the fully autonomous version of V13.3, really. And thus far, I've made some progress on the autonomy side. Let me show you what I'm doing. All right, so right now I have a servo hooked up to a circuit, hooked up to a digital oscilloscope, hooked up to a Raspberry Pi. So quite a lot going on, but let me show you. So say I want to go to a certain degree rather than doing it manually on a transmitter, as you see here. I can simply input it into my program, and the servo moves. All right. If I want to move to what I specified as 105 degree, as you can see here, I hit enter. Oops. Servo moves to 105 degrees. All right, so here really I was able to correlate the degree to the pulse duration as well as the duty cycle. And I did that manually using a transmitter. And once I was able to find the function that correlated the degree to the duty cycle, as you can see here, I simply inputted that into my Python program. And now I'm able to autonomously, or at least have an idea of how to autonomously move this servo. So cool thing about having such a precise function is that, say I want to enter 103 degrees, the servo moves ever so slightly. Or say I want to enter 95 degrees, as you can see here, 95. Then I hit enter. The servo moves ever so slightly, 5 degrees. And so that's really what I've been doing lately. Of course, we're going to have GPS integration as well as accelerometer, gyroscope, and magnetometer integration. And we're also going to have a control system, which is actively in the works. And this is really part of a bigger plan to develop a efficient, low-cost, environmentally friendly transportation solution for really goods to really hit areas such as ones in Haiti, for instance, or really anywhere around the world where there's going to be environmental catastrophe. Hopefully never, but better to be prepared than not. So this is really part of that global preparation, I guess. And here on the oscilloscope, you can see I'm at 95 degrees for servo travel, and that correlates to a 10% duty cycle. As you can see here, 0 degree correlates to 5, 45 degree correlates to 8, and 105 degree correlates to 11% duty cycle. So just to show you, if I enter 0 degrees here, we have we're reading 5% duty cycle as outputted by the Raspberry Pi to the servo. All right. And let's go on the other extreme, 105 degrees. So 105 degree for servo travel. So now the servo has moved 105 degrees. And as expected, we have a 11% duty cycle. All the duty cycle is just a ratio of time on over total period. So really, this is saying that for one period of the signal, the signal is high for 11% of the time. All right, that's really what it means. We could even zoom in to see more of what the signal looks like. So let's see, Y range, zoom in a bit more. Let's try changing the X range as well. Interesting. Y range again. Interesting, interesting. Let's go back to 0 degrees. See what that does. Alright, so now we're at 5% duty cycle as expected. And if we increase the X range a bit, okay, Y range, and then maybe Y offset, move it up. And let's change it's no X offset. No X offset. So still learning, as you can see. But that is really what I've been working on lately. Understanding duty cycles, understanding how that affects the servo travel, and implementing all of this knowledge into Python, a program located inside the Raspberry Pi, which then executes and performs action on the servo. And ultimately, the servo is what is going to move a gimbal attached to the drone in order to provide precise location and positioning as assisted by the GPS and accelerometer, gyroscope, magnetometer setup. So quite a lot of work to do, but it's fun, and I'll have this code up on GitHub as soon as I feel comfortable releasing it. And I already have some GPS code up there that will work regardless of where you are. I already tested it for every single latitude or longitude location possibility, at least within north, south, east, west, and it works out. So that's about it. Thanks for listening, and I'm still around. Just been pretty busy lately.